This is part 1 of the Earth Engine hands-on workshop. I'll be presenting the Earth Engine code editor and the basics of how to use Earth Engine for doing geospatial analysis. We begin the workshop with a tour of the code editor application. When you go to the code.earthengine.google.com URL, you'll see the main user interface for interacting with Earth Engine. This application is divided up into 5 sections, with the largest portion being the interactive map at the bottom of the page. This is where you can view image-based outputs. Just above that, there are 3 panels separated by sliders. On the left, these are essentially inputs. Scripts, images, tables that you've uploaded, documentation about functions, things you use as you build your code. On the right are outputs, things that you print for debugging, charts. If you want to inspect a map and get values out, those go over there. And then there's a tab for long-running tasks, and we'll talk about that towards the end of the class. Top is a search bar, some buttons to do stuff. At this point, it's just best to try it out, and you can see how things work. So what we're going to do first is we are going to learn everything you need to know about JavaScript in about 2 minutes. Honest. Well, I talk really long, so maybe it's more than 2 minutes. But it goes really fast, OK? So we're going to click on this first script, number 0, because, you know, computer scientists, they like their zeros. And what happens is it loads up some code. So this is a saved script. It's one of my saved scripts, but you can, when you write your own code, you'll save your own code. It gets saved in a version control system for you. You don't even need to know that you're using a version control system. You're just saving and retrieving. And this typed some code for you, so you didn't have to type it. The way this works is that first line is a comment, just like in C and many other languages. It's a single line comment. You can also do multi-line comments with star slash and slash star, slash star and star slash. Okay, so you can comment out whole blocks that way. The language that we're using here is JavaScript, and really the only way that you're really going to know that you're using JavaScript is this var thing in the front of your variables. You have to declare your variables before you use them, or as you use them. And the reason that we leave this in here is because it helps you prevent typos. And more specifically, it helps me prevent typos. Because I type 120 words a minute, but every one of them is wrong. And so I typo all the time. And you will see me saying, OK, now we're going to do this, and I'm cutting and pasting code. And that's because if I type it, I can get it wrong. So I try to cut and paste as much as possible. And I try to not even use variable names as much as possible. Whether you want to go that extreme or not, we'll talk about that in a bit. But when you see me cut and paste, go with the cut and paste. Don't try and retype it. This script here is defining some variables. So the very first line defines a variable that happens to be called variable, and it's assigning it the number 1. The second, line number 7 here, is making a variable called string. It happens to be a string. And the strings in JavaScript begin or end with a single quote or a double quote. It doesn't matter which, but you can't mix them. So you've got to start and end with the same one. JavaScript has 2 types of containers. There is a simple ordered list, and I think of it as the simple brackets, so the simple square brackets. And you get things out of this list by position. So the first element is position 0, the second element is position 1, and the third element is position 2, just to be confusing. But the square brackets 2 gets you the 0, 1, 2 element, the -3. Okay? There's another type of container in JavaScript called a dictionary, or also just called an object. And that's a lot more complex, and so it uses the complex brackets, the squiggly brackets. And really, it's just a place to put more variables. So this defines a variable called dictionary. Maybe I could do that with my mouse. Let's talk about that instead of pointing. This creates a variable called dictionary. And inside of that object, there are 4 more variables called A, B, C, and D assigned these values. And you use a colon instead of an equals in here for reasons no one really understands. OK? So dictionary has something in it called A, and it has a value of hello. And it's got something in it called D, and it's my list that I made earlier. So one of these other containers inside of this dictionary container. And then finally, there are 3 lines in here called print, or using the print function. And you can tell it's a function because it's got parentheses. So a name followed by parentheses, that's executing a function. Functions work just like every other language you might have ever used. They take arguments. The arguments have positions, argument 0, 1, 2, 3. Oh, I forgot one step. Getting things out of dictionaries is done with a dot. So getting things out of other objects is a dot. So dictionary.b should be the number 10. List sub 2 should be -3. And we're printing several things here in the last one, and so we should just have 4 items. So that is 80% of everything you need to know about JavaScript. The next 10% you will find when you click the Run button, and that is the JavaScript error. You will get lots and lots and lots of JavaScript errors, I promise. They look like this. Some of them are just as valuable in what they say as this one. As a software engineer, I know that is not defined in this scope means I typed something wrong. You may not know that, but that's what that means. And we could say you typed something wrong, but that's less descriptive. So it's complaining that number doesn't exist. And the reason is complaining is I printed number, but there's nothing in here called number. And so what I probably meant to do was name this number, change it, click run, and stuff happens. So if you haven't done that, do it. Click run, see your results. The complex objects have these little zippies that open and close them. We don't show you everything because they could be really deep and you'd have this big giant console. But everybody got results, 3 lines, 3 prints. OK, great. You are all now official Earth Engine users. Because what you've actually done is you have built a computational description, actually 3 computational descriptions, sent them off to Earth Engine. Earth Engine has evaluated them, returned the results, and the results go into the console. The first computational description is a string. Not real complex there, but you sent a string off to the server, said, please evaluate this. The server evaluated it and returned it, and there you go. You have round-tripped a string through the Earth Engine server. The point here is not, the point here is to teach you a little bit of JavaScript, but also to make sure you have connectivity, right? You round-trip something through the Earth Engine servers. You have connectivity. We can do more complex things now. Capitalization matters. Uppercase, lowercase does matter. And someone's going to immediately ask me about the little I's over here on the left that say you need a semicolon. You don't need semicolons. JavaScript no longer requires semicolons. You don't need them. You shouldn't use them. I recommend not using them. We'll talk about why in a couple more slides. And the last thing, there are multiple different kinds of JavaScript errors. Some of them are just so obvious that we don't even bother. This is not legal JavaScript, and so there's a little red X on the side here. If your code has little red X's, it can't even run, so we won't be able to even give you an error. So you got to get rid of the red X's. Unfortunately, they are not super descriptive because it's broken JavaScript. We don't know what you tried to do there. The best we can do is guess, and the guesses are never very good. And so this one says expected a paren and instead saw a B. That's not really what's going on here. The dot's missing, but there's no way to know that. So you just use the red X's to mean, or you should just think of the red X's as meaning there's something wrong on this line, or maybe the line right above it, or maybe the line right below it. But it's just a general indicator of wrongness in the JavaScript syntax there. Yeah, sometimes we're able to tell you a line number where the error is, and sometimes we're not. And right now, actually, our line numbering is broken. So you really want us to not be able to tell, because otherwise it jumps your code editor around as we try to tell you, hey, it's on line 71, but in fact, it's on line 300. So we're going to get that fixed. And in general, we try to tell you, but we can't always for long, complicated reasons that I don't want to go into. But we can tell you sometimes, and we can't others. Any other questions? OK, you are all now JavaScript experts, and you can go have a lucrative career in web development. See you. All right. We're going to click on, there's a little bit more JavaScript you need to understand, and this is the first real exercising of the Earth Engine system that we're going to do, and that's the next script. So go ahead and click on the next script. It's going to ask you, do you want to save this or not? Don't save yet, because there's a first time long process that we'll go through in a second when there's actually something you want to save. Okay, so go ahead and load script 1. And we'll talk about what's here. So first line is obviously a comment. The second line is making a variable that is a list of strings. And this particular list is an EE list, an Earth Engine list. We'll talk about that in just a second. This is what you might have expected from the previous slide, a list of strings, an ordered list of strings. But I want to do things on the Earth Engine server with this list. And so I need to make it not a JavaScript list, but an Earth Engine list. And the way you do that is you wrap this with the function called list inside of the object that contains all the Earth Engine stuff. So EE is where all the Earth Engine functions live. One of those functions is called list. So we're getting the list function out of the EE object and giving it a JavaScript list to turn into an Earth Engine list. We always have trouble here, so if that was not clear, that was a new way of saying it. If that was not clear, let me know, and we'll go over it again. But we're just making a list of strings. They happen to be dates. The next thing we're doing, and this is the last bit of JavaScript you actually need to learn how to do, is we're going to make a function. And that function is going to take something. It happens to be called date, but I could call it x or foo or anything. It's just taking something and sticking it into a variable called date. And then inside the body of the function, which is everything between these curly braces, we do something with that thing that came in. So in this case, we're getting something that we expect to be a date. We call it date. We're going to turn it into an EE date object. And then we're going to do something with it by calling a function on that new object. So inside the EE object, there's a date function. That makes a date. Inside of that date, there's a whole bunch more functions for operating on that date. And one of those functions is called getRelative. And what it will do is it will get part of the date relative to some other part of the date. So I'm getting the day relative to the year, or day of year. You could get minute relative to the day, and that's how many minutes have passed since the midnight of the day. Or you could get seconds of the year, how many seconds have passed since the beginning of the year. So get a number relative to some other part of the date. And so this function, and the result is returned, right? So it's returning that relative number. What this function does is it converts one of these strings into a day of year number. So it's going to, when we call it with our inputs, it's going to convert 2012-08-14 into a day of year. And my hypothesis, or my thesis here is that these are peak growing season dates, and we want to get the average of all of them or something like that. Okay? So the average day of year. The next 3 lines print our list of dates. When we run it, you'll see here are our 4 dates in a list. And then we're going to map our function over those dates. So we've got a list of 4 dates. We're going to map a function over it, which means it's going to apply our function to every one of the objects in the list. And we're going to get out another list, which is the results. 4 strings in, 4 numbers out, because our function converts string to number. Does that make sense? Too fast? Glazy eyes?
Is year, month, date the only format that comes for date?
No. I don't remember. But there are docs, and we will find that out right now. We'll find that out in 2 minutes, actually. So we mapped our function over all of our dates, and we got out 4 new day of years. Yep, that makes sense? And then the last line, oh, yes? There is a day of year 0, yes. Depends on what kind of person you are. I'm a zero-based person. I think that's true. We can find out really quick. I believe it's zero-based, but 0, 1, 0, 1, turns out, yeah, it's zero-based. So if you want one-based, you gotta do something about it. Okay, so this last line is, again, applying the mapped function, mapping the function over our list, but then we're going to reduce all the results. And we're going to make a mean reducer and stick all the results into it, and we're going to get the mean day of year of all of our peak growing season dates. And that turns out to be, when you don't do what I did here, that turns out to be 234. So our mean day from these dates is day 234. Questions? If you've programmed and you've built functions before, this syntax here will make sense. Pass in date, use date. But this is like the #1 place everybody gets hung up on functions. You're passing in something, or something gets passed in for you, and it's going into a variable. I keep trying to want to point up there. It goes into a variable called date automatically. That's just the way functions work. It's gone, the thing that came in goes into a variable called date, and then you're going to use that inside the function. I could call this foo, and then I could use foo in here. Does the same thing. Okay, it's just a variable, and then we have to use that variable. Questions? Ooh.
So, how is the print connected with the function? Because I don't see how it.
We are mapping the function over our list of dates.
Yeah, but
Dates has a function on it called map. That function takes a function and applies it to every element inside of the container.
so what we put in the bracket doesn't have to be like dates instead. For example, at the beginning it says var dates, and then we have the list, right? I was expecting we have to bring that date down there.
Yeah, you were probably expecting something like day of year for dates, or
Yeah.
the function called on it. Map works the other way around. You give it a function and it applies the function for you. And you give it a function usually on the container. So you might have an image collection, you're going to map a function over it, it works exactly the same way. Okay? This is the #1 most important thing to learn. So if this doesn't make sense, neither will the rest of the day. Okay?
Why we use only the day and the year? What about the month?
I don't care about the month. My goal is to convert dates to day of year. I'm trying to get an average day of year. Month doesn't enter into that computation. I just want to know day of year. Sure. Probably here, but it may want a cast. Yeah, that's what I thought. I'll show you how to do that in just a bit. Okay, it involves a thing we haven't learned yet.
How can we get the count for?
Right. So you asked about what does get relative have. There's two answers. The first one is there's a docs tab, and you can just simply search in the docs tab for get relative. Relative, and there's the function, and there's the docs about the function. Hey, look, zero-based unit. I should have just looked at the docs. And so you can get month to year, day to month, minute to week, whatever combination of those you want. Okay? So the docs tab, there are a lot of functions. So if you just want to kind of browse them, here's everything you can do to a date. There is not an example attached to each function yet. Okay? One more.
So day of year is the name of this function.
Yes, and it produces day of year numbers.
So we use that to wrap something or map around the naming, the main thing.
We are applying that function to every element in a container using map. Let me rewrite this the way you're expecting it to be written, and don't ever do this. Okay? So you might want to be doing I equals 0, I is less than dates.length, I plus plus, plus plus, result sub I equals day of year dates sub I. Okay? I'm assuming this makes more sense to you, like that's how you'd write something. That's exactly what just happened with map. Map loops over all the items, so 0 to length, calls the function on each item, and captures the result. But I didn't need a new result object. I didn't need to deal with indexing. It all just happens for me because of map. So this stuff and this are exactly the same, except it all happened on the server. If I have not 4 dates, but 40 billion dates, that's all on the server. I'm not moving around 40 billion dates. The server's dealing with that. Whereas if I had this for loop, I'd actually have to deal with 40 billion dates and 40 billion loops. And no, don't do that. Okay?
So if we list dates as strings, it will not recognize. You always have to convert them into the EE date. Right?
The question is, do I always have to convert my dates into EE date objects? And the answer is no, mostly. So we'll do promotion. Anywhere that's expecting a date and you pass in that string, it will automatically promote for you. But there's nothing in our function that is expecting, right? We need something to start with. We need to get a date first, and then we can do things with it. So other places where you're perhaps filtering by a date, the filter function just takes a date, and you can either pass in a date object or a string, and we'll promote the string up to a date object for you. But here, there's nothing to start with. I have to start with a date by creating it. Okay? Okay, oh, one more.
Is it possible to save the results of like the map in its own list rather than just printing them?
Yeah, sure. The question is, can I save the results into a list? And so I could do result is dates map of year, and then I've got a new variable to do stuff with. So instead of doing this again, I could do result.reduce, and say average, and then do something with the average, but I'm just going to print it. And so those are exactly the same. And they are, in fact, exactly the same. The server sees the exact same code. Nothing has changed, even though you use new variables. And you might think, oh, I saved doing this map. I didn't have to do it twice because I put it into a variable. Technically, that's sort of true, but Earth Engine doesn't care. When you pass over that computational description, it rips out all of the pieces that are identical and just does them once. And that is the crux of why we use a functional language, is because it's safe to do that in a functional language. You didn't care about that, but that's why. Okay. So using Earth Engine is this slide, just with images and collections and lists and functions. And you just do a lot of this, and you're there. Okay? So let's see how that works. From here on out, I'm actually not going to use the rest of the scripts in this. These are fallbacks in case you get lost or you want to see it next week. And in fact, I'm probably going to deviate from where they go a little bit as you ask me questions and want to see new things. But you've already seen the run button. Right next to it is a reset button. And beneath that, there is a clear script option. So let's just start with a clear script. And we're going to do some real stuff now. Like no more playing, real stuff. Okay? So the first thing we're going to do is we're going to go get an image to work with, because lists are fun, but only if you're a computer scientist. So let's go get an image. We're going to find something. If you want to find anything at Google, that really means search. So we're going to search for an image. I want to go get some elevation data, but you might want something else. So maybe you want surface temperature. So you start typing surface temperature, and we'll tell you all the surface temperature data sets we have. Or maybe you want nighttime lights, and start typing that, and we'll tell you all of the nighttime lights we have. But right now, what I want is elevation. So we're going to type in elevation. It will autocomplete faster than this. There we go. And I actually want the SRTM digital elevation data at 30 meters. So that's like number 6 or 7 for me. Okay. Click on that line, and it will pop up a data set description about that data. Tells you bands and scaling and band names and provider and more or less everything we know about that image or that data. And this is where you learn, oh, that data is scaled or not, or what is the resolution or something like that. And what we want off this page right now is the image ID. So we're going to cut and paste this image ID. There are other options, but right now we're going to cut and paste it and stick that into our script. Okay? And we're going to turn that into an image, sort of. There's 70 people doing the exact same thing at the exact same second, so it should go pretty fast, but it might take just a second. Clear it out and do it again, and it'll send a new one. Are you on? You're on the network, right? I mean, obviously you can see the code editor. Nick, see what you can do here. Who else is having trouble getting a list, getting a search? Just here. Check network and whatnot. We'll let her catch up in a second. But we're going to turn this into an image, and we're going to do that the same way we made the list. Whoops. And I can make this font bigger so you can actually see. How's that? So image is a function inside of the EE object. If you can just type it, I mean, it's not very many characters. You can just type it and get there. Image is an object. Image is a function inside the EE object. It creates an image, and it takes the ID of an image to be able to do that. Almost. That's actually a complete lie. It does nothing. It creates an object that will eventually be an image on the server at some point in the future. But right now, it's just a proxy object with nothing in it. So if you happen to be a JavaScript person, or when you're in the Python, if you happen to be a Python person, you cannot rip this object open and fiddle around with the stuff inside of it, because there's nothing inside of it. It is just a proxy object for something that will happen later when it gets to the server. So thinking about that, if I click run right now, what happens? Nothing. Because I didn't do anything with this object, and this isn't even a real object. It just made a proxy object and then dropped it on the floor because it didn't do anything. So we're going to do something with it. We will round trip through the server, and it will say, oh, you want to print an image. I will just tell you what I have about the image, and there's information about that image. It's bands, projection, that sort of stuff. Okay? But printing an image is not very fun. So instead of printing this image, we're going to add it to our map so we can see it. Just like there's an EE object with all the EE functions on it, all the server functions on it, there's a map object with all of the commands to be able to modify the map or play with the map. So instead of printing, we are going to do map add layer. Oops, you can't see any part of that. Where'd it go? Come on, come back, come back, come back. All right, we'll just go with that for now. Okay. So capital M map, that's the main map that's this thing down here, and we're going to add a layer to it. And add layer tries to be really smart. You can give it almost anything, and it will try to figure out how to stick it on the map. About the only thing you can't do that with is numbers. Like you can't give it the number 10. It doesn't really want to try to do that. And lists and dictionaries. It doesn't know what to do with those either. But features, images, image collections, feature collections, polygons, geometries, all that stuff, it will figure out how to draw it and draw it on the map for you. So we click run. A few seconds later, we have an image. That was about 50 milliseconds per tile. It's a really ugly image. We didn't do any processing, but I'm going to keep hammering home. This runs really, really fast most of the time. Everybody got an ugly image?
Quick question. Did you type something by mistake? Is there an undo command?
Command Z. Yeah. Or Control Z. I mean, one of those two. I'll talk about shortcuts in a second. Everybody's got an ugly image? OK. The reason this image is ugly is we didn't do any visualization on it.
Question. What is the difference between, because I saw that there was also the import capability.
Yep, we'll talk about that in a little bit as well. It just does some typing for you. The reason this image is ugly is we haven't specified any visualization parameters, and it doesn't know how to stretch it. So we're going to do that next. We'll get into some details, but right now I'm just going to tell you that the second argument to map add layer is some visualization stuff. And what you can do is you can just make a dictionary out of some stuff. Oh, come on, give me a second. My editor is not participating. There we go. What we're going to do is we're just going to make a dictionary right here in the middle of this function and give it two variables, one called max and one called min, and we're going to specify the min and the max values to stretch this image with. And what's happened is we have assigned black to the minimum value and white to the maximum value, and we're doing linear interpolation between them. And anything below min is black, and anything above max is white. Straight up in linear interpolation with a default palette of black to white. Okay? That's what you got a second ago, except min was probably minus 65,000 and max was probably positive 65,000 because it just didn't know. But now we set some limits. If you don't like black to white, you can specify a palette here. And you can go, for instance, blue, green, yellow, and red. This is an ordered list inside of my inline dictionary, right? So I just create a list right here. They're ordered. Assign it to the variable named palette inside of this anonymous dictionary. And the same thing happens that happened a second ago. The first color is assigned to min. The last color is assigned to max, and we just linearly stretch between them. But a minute ago, we were defaulting to black and white. But it was still first color to min, last color to max. Does everybody now have a not so ugly image, depending on your aesthetic and palette choices? You can put as many colors in there as you want. It's all just linear stretching or linear interpolation done this way. One of the nice things about linear interpolation is it works upside down. So we can actually specify a min of 3,000 and a max of 0, and it will invert our color map because it's just linear interpolation. It doesn't care. First color goes to min, last color goes to max, linear interpolation between them.
Is there a dictionary of colors that we can refer to?
Right now, this second, you can put any www color in there. So there are lists of those colors on the web, and you can also use normal, well, normal for me, red, green, blue triplets. Okay, but yeah, some do, some don't. So if you just look up, no, I don't have a list handy, but if you look up www colors. Nope, don't go there. Don't go there. W3C is what I want, W3C colors. So HTML color names, okay? I have a whole color and palette system waiting to check in as soon as my engineers get home and can actually review it, so that you don't have to mess quite so much with colors and palettes the way you do right now. Okay, everybody's got a pretty image? We're going to do one more thing to this image because we'll want it later. But this is all linear interpolation. So we're getting oranges and cyans and colors that are not one of the 4 colors we specified. And sometimes you want discrete colors because you're doing maybe a classification or something like that. So I'm going to show you how to, I'm going to show you one of the cool features of Earth Engine as a proxy, by way of showing you how to do some level setting. So we are going to make a function called, or make an object called levels. And we're going to take our image, and there are about 200 functions that you can do to an image, many, many, many of them. The one we're going to do is called where. And everywhere this image is greater than 0, we're going to set to 0. Go with me for a minute. So image greater than 0 gets 0. And then we're going to do a nifty thing. Everywhere that image is greater than 200 gets 200. And now we're going to cut and paste because typos. Everywhere that image is greater than 400 gets 400, and 600. I probably should use bigger numbers, but these will work. Anywhere greater than 600 gets 600. So this is a form of truncation, but really what I'm showing you is conditional replacement. This is a test. Everywhere that test is true, the image gets replaced with this value. And this can also be another image. And now if we put that on the map, we know that our mins and maxes are 0 and 6. And now we're going to stick this exact color palette in here and map that. So the level set part of this is not the important part of this demo. The important part is this bit in the middle here where we've got lines that start with dot. And what I did here is called method chaining. Images have a bunch of functions on them. When it's a function on an image, it's called a method. That's an image method. And I have chained together 4 of them. I could have done this in 4 different lines. I could have said, OK, that's that one. And levels 1 is levels.where that. And then levels 2 is levels 1, where that. And level 3 is level 2, where that. OK, those are identical. But I've introduced 4 new variables, 3 of which I'm only ever using once. And if you find yourself using variables once and never again, that's probably a prime candidate for method chaining and skipping a fair bit of cognitive load. You don't need to think about the fact that there's 4 variables there. You're just taking the output from the previous step, applying a new function to it, and returning it, but not exactly. Okay? And so that's what method chaining is doing. Take this thing and apply a new function to it. And so the white space is unimportant. We can actually do this all on one line. And maybe that'll make more sense to you if you like. But these are big giant lines. I don't like that. And so I like method chaining that looks like this. And I find that super intuitive to read. We're just doing a chain of operations to this variable. And more importantly, at some point, you might ask for help, and I'm going to send you back a really quick response, because I answer about 50 of those a day. And so I will quickly dash out some code, and it will look a lot like this, and you'll go, what the heck was that? Well, now you know. Method chaining, it's good for you, and I think it makes for a much easier to read code. Okay? Questions?
If we change the sequence of these conditions, for example, starting from 600
In this particular case, I'm using image each time, and image doesn't change. So this particular sequence won't matter if you change them. If you were not doing the method chaining, I can't get there from here, can I? If you were putting them in multiple variables and referencing the previous variable, then it would matter the order that you do it in. But an important concept, and this may not make sense to most of you, but go with it. Things in Earth Engine are immutable. Once you've made a thing, you can't change it. All you can do is make a copy of it that has changes applied to it. So image, we've already made, nothing we can do to it. We can make a new image, which is a copy of image where we're doing this function to it. And whatever that result is, we can make another one of those that's a copy with changes applied to it. And another one of those that's a copy with changes applied to it. So this actually makes 1, 2, 3, 4, 5 images along the way, 4 of which we just never touch a second time. And along the way, image certainly didn't change as we were doing this. And half of you are like, whatever. Okay? Objects in Earth Engine are immutable. Okay? Everybody have a nice, pretty, discrete color image here? Okay. Now we're going to do something else, but this is a great time to exercise our save function. But before you click on save, if you're a brand new Earth Engine user, you're going to click that button, and it's going to ask you not one question of what do you want to save your file as, but 3 questions. It's going to say, what do you want your username? And if you don't read that first prompt, you're going to end up called my first script. We have a lot of users named my first script or some variant thereof, and that's really, really hard to change. So read that first prompt. It's going to say text, 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 users blank. That blank is what do you want to be called? I usually recommend everything on the left side of your email address. I'm Gorlick at Google, so I am Gorlick. You can put in anything you want, but I'm just saying you probably don't want to be called my first script. And it's a lot easier if we can look up your home directory, your user directory by your name. So choose carefully, but go ahead and click the Save button. And read what it says this first time. The first time it wants to know, what do you want your username? The second time it wants to know, what do you want your home directory to be called? And that one's easy to change. So if you mess that one up, that's fine. But then the third one is, what do you want the name of the script to be? Okay? You only get asked these first 2 questions once, but it's right now. So be careful as you answer them. If you have a problem, raise your hand.
I've done this a long time ago. I'm not sure if I'm not my first.
It will say here on the left-hand side, users something something. So whatever that is for you at the top under owner, if you like those, you're good to go. Okay, everybody saved? Anybody need more time? Great, we'll go onward. So that was one image. We can do all kinds of cool stuff with one image, but really, if you just want to process one image, Earth Engine's probably not the best tool for to choose. Our strength lies in the ability to do massive parallel processing, and frankly, there are easier tools to use if you just want to colorize an image and move on. Like you might be able to do this with QGIS just fine. What we're going to do next is we're going to work with some really massive data. We're going to work with the entire Landsat 8 collection here in just a second. Okay? So let's clear this script, or you can comment it out either way. But it will be easier if you clear it for now. And we're going to go get some Landsat data. So the way we find data is to start searching. And here is a small subset of all the Landsat 8 data that we have. Who doesn't use Landsat? OK, no, that's fine. Landsat's a series of satellites that have been flying since 1972. They're currently on number 8. They are generally optical, near-infrared, shortwave infrared, and now thermal bands, so about 10 bands per instrument. The current new instrument is Landsat 8, but there's also Landsat 7 flying right now, and a bunch of data from Landsat 5 before that. Until recently, if you wanted Landsat data, you just go and get it out of the USGS, and they happen to be using, they happen to process the imagery with whatever calibration was current at the time. And that caused a problem if you downloaded a lot of imagery over time. You might have calibration 4 and calibration 4.3 and calibration 4.8, and really the data wasn't mashable. And so that became a problem. And they recently fixed all that by going to a system called Collection 1. They reprocessed the entire 8 million scenes from all the Landsat images, all the Landsat imagers, into one common calibration, both radiometrically and geometrically. And that's called Collection 1. Inside of Collection 1, there are 2 types of data. There is Tier 1, which is the good stuff. There's Tier 2, which is the not so good stuff. You probably want Tier 1. And then when we get data, we do a couple different things to it. We have the raw data. We have the data converted to top of atmosphere reflectance, which is a thing lots of people want. And we have the data converted to surface reflectance, which is a thing some people want, depending on your particular preferences. What we're going to get, now that I've said all that, Landsat 8, Collection 1, Tier 1, TOA reflectance. Right there. Click on that. And we'll show you bands and scalings and all kinds of stuff. Like I said, it's got optical bands and near infrared and shortwave infrared and a few others. But this time, we're actually going to click our import button so you can see what it does. I hate this button for reasons. You might like it. You might think it's awesome. But what it does when you click it is it closes up the screen, but it types some code for you. It created a new section at the top of your script called imports. And that's a place where we type some code for you because we know what the code means. We just typed it, so we know what it means. You can't really change the code up there. But because we know what it means, we can give you a little bit more UI information, some options. If you click on this blue bit, it will bring back the dataset description. And so this is a really fast way to get back to a dataset description rather than going through the search box again. And we name it for you. So we made a variable called image collection. It contains the Landsat 8 image collection. And if you want to see what we actually typed, you click the little blue box here, and we'll show you what we typed for you. Okay? And this looks a lot like creating an image. It's just a function called image collection. It takes a string, it makes an image collection object, and we can do things with it. And the reason I don't like this is I really like method chaining. And now I've got this variable up there that I can't really method chain on anymore. I'm going to do a step here that 10 of you are going to miss, so pay attention for a second. I'm going to click on this variable name, and I'm going to call it L8, because I like short variables. And if you had been using this variable in your script, it's going to rename it for you all the way through your script, which is kind of nice. So there are reasons to use the imports. That's one of them. But I would now like to do things to this collection, and I can't. I can't just chain to do it. I have to actually reference the collection. So I want short names to do that because I type terribly. Okay? So the very first thing we're going to do, or the very first, you don't need to do this because it's going to be the exact same answer. But the very first thing I want to do is just see how big this thing is. So the collection has a function on it called size. This will take a little bit to run, and I'll keep talking while it's running. But I want you to know what you're starting with and how many images and what's about to happen. I happen to know the number is 800,000. While that's happening, there we go, 830,000 images. So we're about to do something to 830,000 images. I hope you're happy about that, right? You should be excited about being able to do something to the entire Landsat 8 collection all at once. The very first thing I want to do, and more or less the very first thing I do whenever I'm working with any data in Earth Engine, is I don't want to print it. I want to stick it on a map. I just stick everything on a map. And that will take a few seconds to load. And this is a loading progress indicator. As long as there are tiles still to be processed, there will be the progress bar will still be gray. And turns out 800,000 images take a little while to process. So you can leave this running, but let's get down to Washington so that we're working on less data. So we zoom into Washington. We're all doing this at exactly the same time, which is exactly the thing Earth Engine is not built for, but it will catch up. Okay? And so now it's loaded every bit of the Landsat collection that you can see. Earth Engine is a lazy evaluation system. It doesn't do anything it didn't need to do, and I am not currently looking at Utah, so it did not load the images over Utah. I'm looking at Washington. It's only loaded the images over Washington. It's only processing the tiles that you're trying to look at. When I typed in Washington and just accepted it, it set me at a screen resolution of 300 meters per pixel. So you remember back to our tile pyramid, it's actually pulling in just the scenes over Washington, and it's pulling them at 300-ish meters per pixel. Okay? And it runs pretty fast. It is, however, a terrible image. We really can't do anything with this image because we haven't told it what we want. Because we didn't tell it anything, it went and it got the first 3 bands. And the first 3 bands are coastal aerosol, blue, and green. And that is never a band combination you want. I promise you don't want this band combination. What you might want is red, green, and blue. Or maybe near infrared, red and green. So if you're a false color person, that's what we're going to do. If you are a true color person, then you might want to do red, green, and blue. I need to know which bands I want it to display, and so I'm going to do band 5, band 4, and band 3. False color, near infrared. Okay? So 5, 4, and 3. So just like before, we can add some visualization parameters. This is an ordered list. And I'm going to stretch it up a little bit because I'm using TOA, and I kind of know the maximum values for TOA. I want a min of 0 and a max of about 0.3, maybe 0.5. And I got an error. My error is, oh, missing a square bracket. Yes? The raw scenes are not calibrated for sun distance, so the radiance moves around a lot more. Top of atmosphere is calibrated for, it's actually at sensor reflectance, but it's calibrated for solar distance, time of year, that sort of stuff. But it still has all the atmosphere in it.
So we should wait for the DOE one.
Probably. Depends on what you're doing, but if you don't know what you're doing, either use surface reflectance or TOA to get started. All right, so does everybody have a slightly less ugly image? In this case, bright red. This band combination highlights vegetation. I just picked one. But it's still got a lot of clouds in it. The water's dark, that's kind of nice. If we zoom out a little bit, you will see all these squares. Wow, that's a little slow. Each of these squares is a Landsat path row. Right here on the screen, I've got maybe 15, 16 path rows. And all the data for all the years, which may or may not be what you want to do. What I want to do is try to make a maximum NDVI composite, and then we're going to do stuff with our max NDVI composite. Okay? So to do that, I have a couple options. What I'm going to do first is I'm going to try to composite together composite these images together to remove or reduce or reduce or remove clouds, right? Because these clouds don't really help me in NDVI space. Anyone not know what NDVI is? Totally plausible? No? Really? It's okay if you don't. All right, cool. So the clouds are in the way. We're going to try some simple techniques to remove the clouds or minimize the clouds. At any point here on this screen, if I inspect, I get to see not only the pixel that I clicked on and the band values for that pixel, I can actually see the entire series of pixel values across all bands here in the inspector panel. And if I was smart and clever, I could probably look at this quality band and determine which of those are clouds and which of them aren't, but I am neither. And so it just some of this means clouds and some of it doesn't, and there's a lot of both. And so some statistical techniques for removing clouds here may or may not work. The first thing we're going to try is just to do a median composite. And what that does is for that stack of 99 images that at that point where I clicked, or 150 just a little to the left, or 180 a little to the right, it's going to take each band, it's going to sort all of the values on that pixel for every pixel, and it's going to take the one in the middle. So it's a median pixel per band, and we're going to get out an 11-band median composite. Okay? The idea here is that clouds are bright, shadows are dark, and maybe that middle value is cloud-free. We don't know what date it's going to come from, but maybe it's cloud-free, and we might get a cloud-free composite this way. And not so much, right? This means that it is cloudier. It is cloudy more than 50% of the time here. Median didn't get us there. But along the way, we learned, hey, we can do deep stack compositing really easily. Deep stack statistics often are as simple as that. Or if you want to do something a little more complex, you might do reduce with a median reducer. Because the only 5 that have shortcuts are min, max, mean, mode, and median. If you want to do Pearson's correlation, I don't have a shortcut for that. You have to make a real Pearson's correlation reducer. Pearson's correlation, which I spelled wrong, but you get the idea. Okay. The difference between this way and the other way that I just showed you a second ago is that this way renames the bands. It reduces each band, and because it doesn't quite know what you're doing, it sticks the name of the reducer on the end of the band. So if we just run this, it's going to say, what? I don't know what you mean. Error in my console. The console turns orange. And it says the bands that are available are B5 median, not B5. So we could rename our bands real quick. We could pick different bands to do. Or in fact, I don't care about either of these because median composite really didn't do what I wanted. So I'm not going to do either of those just yet. I'm going to back up to just my L8 composite. And do something else. Okay? So I did a median. There were clouds in it. What happens if I do max? What am I going to get? All clouds. What happens if I do min? Probably no clouds because it's all shadow. And so that doesn't help me either. What happens if I do mean? They'll just get merged, they'll get squished in the middle with everything else, and I definitely don't want that in this case. So those statistics don't help me here. I can't really get simple statistics and make a nice cloud-free composite here. This is the point where I point out how you would do this properly, but we're not gonna, we're gonna do something else. And the proper way to do this is down here in the examples, inside the code editor. At the bottom of examples, there's a whole bunch of cloud masking techniques. And these are scripts that will show you how to use the quality bits that come with the data to mask out what the provider thinks are clouds. But they're a little fiddly, and I don't want to go into them just yet. I'm going to do something a little simpler just so we've got a composite to work with, okay? You with me? All right. So what we're going to do instead is we are going to make a composite. And because this particular step is a thing that happens a lot, we have a nice function for doing what we're about to do. ee.algorithms.landsat.simplecomposite. Clear and obvious naming. Yeah, you'd have thought of that, wouldn't you? No. This is why there's a whole reference on how to find, how to do things. But what Simple Composite does is it computes a cloud score for every single pixel, and it takes what it thinks is the least cloudy pixel, just so you can have a cloud-free composite to start working with. That may or may not be a scientifically valid composite, that you don't really know which pixel got picked, but I just want a composite to work with right now, and so this is plenty fine for basically visualization purposes. Okay? We'll do something a little more complex here in just a second. A thing I wanted to show you was auto-completion. This was a long thing to type, wasn't it? You don't have to. If you are back up here, you can complete and see the options. On my Mac, this is control space. On your Windows box, control space probably reboots the internet. I don't know, but be careful. It's something like control space. If you've remapped your keyboard, like some of you might have international computers and you use control space to go back and forth between keyboards, too bad, you don't get this key. But if you can get the autocomplete to come up, it will say, well, here's the things that match, pick one. And so I will take Simple Composite. And now, the second cool thing about about autocomplete is that some of our functions have a lot of options. I think there are a couple that have 27 arguments. I hate typing 27 arguments, especially if I'm only using the first one and the last one. Like filling in those 25 in the middle is just excruciating for me. In Python, you don't have to do that. You say, argument 1 is this, argument 27 is that, I'm done. JavaScript doesn't know how to do that, never has. I'm a software engineer. I make things like JavaScript do my bidding. So what I did is I invented a way to do keyword arguments in JavaScript. And the autocomplete helps you get there. So if you're right here, inside the parentheses with nothing after this, and you autocomplete, it will fill in the name of all of the arguments that this function understands. And that doesn't help you so much just yet. If you do it again right here, it will pop up the help. And you can read about those arguments without having to go all the way to the help. But generally, those arguments are pretty well named to give you some indication of what they're for. And now you can do this. I want to make a dictionary with my collection. And I only want to use the first and last arguments. Inline dictionary. We use it a lot in Earth Engine. And so now, keyword arguments in JavaScript. I'm probably not the first person to invent that, but I tell everyone that I invented that, because I really like it. Now we have one more problem here, and this is one of the reasons I hate the import button. Simple Composite wants raw Landsat scenes. And we've given it top of atmosphere scenes. And it's going to go, I don't know what to do with that. And now I have to go fiddle with my imports. But what I'm going to do, you can do it the same way. You can get there however you want to do. I'm going to open up the little blue box. I'm going to take that piece of code, and I'm going to copy and paste it into my code so I can do what I originally would have wanted to do. And I'm just going to take off the TOA part. And now I don't need my import any longer. Okay? So blue box that shows you the text. Copy and paste that text into the top of your script, and you can modify this import. Do whatever you want to with this import. And now I'm deleting my import. They are helpful. The imports are helpful. Importing data sets is helpful until you really try to start doing things with them, and then it's often just easier to work with the raw text. Okay? And now instead of adding my layer, I'm going to add a composite, or add my composite. And composite. In theory, I should have a nice cloud-free image. So simple composite computes TOA for you, computes a cloud score for every pixel, and selects what it thinks is the least cloudy pixel. And we end up with a cloud-free composite to start working with. Correct. It is at least representative of a single day per pixel, whereas the median composite may not have been. It's taking the median in every band independently. So the red band may have come from January and the blue band may have come from December. That's just the way those compositors work. If you want a medioid instead of a median, where you get like the median red and then all the other bands from the same date, there's ways to do that. We'll talk about that a little bit in a second. Right, yes, exactly. So you're perfect prompting. I am a software engineer, which means I am lazy. I also have a very short attention span. And this took longer to come in than I care about. And there might be a scientific reason to do what I'm about to do. Take your pick. Are you lazy, or is there a scientific reason? We're using the entire Landsat collection and taking the least cloudy pixel. And that means that my pixels might be spread over 4 or 5 years. That may not be what you want. And so where I'm headed here is to do a 1-year maximum NDVI composite. So let's filter this down to 1 year. And it will run 4 or 5 times faster. Also, actual knowledge of what data I'm using. And finally, if I had had a semicolon on the end of that line, or all these lines, like JavaScript suggests, I would have had to remove that semicolon to put this filter date in. And that I do all the time. I just pop in new functions as part of method chaining all over the place. And so I despise code with semicolons in it, because I have to go remove them. So I recommend not bothering with the semicolons ever. Okay? Yep.
Would this method work for Landsat 7 to kind of get rid of the stripes?
A little bit, yeah. You can do destriping with this. It won't necessarily remove them all. You may still see a little bit of them, like I showed you in the time-lapse data. There may still be just some artifacts from that. But yeah, you can composite together through time to fill in Landsat 7 that way. Everybody good? Anybody need more time? You need more time?
I have a question.
Yep.
So after the filter, it's down to 1 year, and if I zoom in, there's black spaces or black pixels. Is that where hasn't been cloud-free image all year?
Not if it's black.
So it seems like a lot of that, which doesn't seem like or is that
If you go to a red, green, blue, you might find that those are actually something.
okay.
Offhand, I don't know.
Okay.
Those are just places that are super low infrared, and I don't know what that means. But if there were missing pixels, they'd be transparent. You'd be able to see through them.
Sorry, I just forgot. Why did you remove the TOA from the image?
Because simple composite wants raw data, because it computes TOA for you. Okay, so now we have an image. This is our starting point. I just wanted to get an image so we can start doing stuff with it. You will note if you zoom out, it's an image for the whole world. This will take a few seconds to load. I'll just leave it running. But what we're going to do now is, now that we have this image, we're going to compute NDVI with it to learn how to do NDVI in Earth Engine. And once we learned how to do it for one image, I'm going to show you how to do it for 800,000 images. And then we'll get our maximum NDVI composite out of that. Okay? Cool? All right. I'm not going to wait for all those tiles to load. I'm going to go back to Washington, and we will compute NDVI for Washington, or computing it for the whole world. We're just only displaying it for Washington. So what you would like to be able to do, so NDVI is near infrared minus red, right? That's the start. So you would like to be able to do near infrared minus red divided by near infrared plus red. The difference of these two bands divided by their sum. That's what you want to be able to do. You can't. You can get close, but it's a little unpleasant. And we'll start by getting our near infrared band and our red band out. So we're going to do composite.select band 5 and composite.select band 4. So that's our red band and our near infrared band. And what you want to be able to do is say something like that. And there's more, but we'll just start with that. You don't need to type line 14. It's not going to work. Also, you have to be able to spell. So when I try to add these two objects together, remember I told you these are not images. These are proxy objects for something that will be an image sometime in the future when it gets to the server. But right now, it's just a proxy object. And if I try to add these two proxy objects here in my browser, that happens now, not in the future. So I've got one proxy object and I've got another proxy object, and I try to add them together, and JavaScript helpfully says, oh, you're trying to add two objects. I will convert those to strings for you and stick them together, which is clearly what we wanted. Not. And here's what you get. This is what our proxy objects have in them. A whole bunch of code in a functional language. Here's the first image. Here's the second image. And it just stuck them together. Yay! No, that's wrong. That's not what we want. So you can't use plus, minus, divide, multiply. You can't use those operators here in your Earth Engine code because they happen now. They don't happen on the server in the future. Okay? This is the second most common place people get stuck. To do anything on Earth Engine, you have to use a function. Anything. To do anything at all, you have to use a function. So if I want to add two images or subtract two images, I need to do a function. And that's just horrible, isn't it? NDVI is only 4 terms. And so you could perhaps type this and not get it wrong, like we just did. But if you're trying to do surface albedo, that's 29 terms. You're going to get it wrong. I get it wrong. Everybody will get that wrong, because that's not the way we do math in our head, having been taught how to do math for gazillions of years that we were in school. So when you want to do a lot of math, this is not the way to do it. When you want to do a little bit of math, this might be the simplest way for you to get there. Like if you just want to divide by 10, divide by 10. This is the better way. But you want to do something complex, you need a better way to do it. But as I just said, to do anything in Earth Engine, you have to use a function. So there's a function for that. there is a function called expression. And here, you can do this. But you are introducing new variables. And so you have to define them. And you do that with a dictionary. Okay, so the variables inside this string have nothing to do with variables anywhere else in your code. These are variables that the server will get. You know, it will get this string, and it will then say, okay, what are these variables? And so you need to tell it, and you tell it with a dictionary. Similar to NDVI, there's another one called EVI, and it's got more terms and some big giant L constant on the end, depending on your sensor. You can actually stick constants in here, and the right thing will happen. Right? This is where promotion happens for you automatically. That is not a real term. That's not a real equation, so don't stick with it. But I'm just pointing out, whatever you use up in here, you need to define. And you can rely on promotion to do the right thing for other types. All right, I hear less typing. Everybody's got 2 NDVI images. You can toggle between them. I will take this opportunity to talk a little bit about the layers panel more. I've got 3 add layers in my map. That gave me 3 layers here in my panel. They're just called layer 1, layer 2, and layer 3 because we didn't know what to call them. The third argument to add layer is a way to tell us the easy way. Easy way. A way to label those. So now NDVI, the easy way, is the name of the layer. And when I inspect, that's what I'll see as well. This?
Yeah. Click on layers.
Yeah, just hover on layers, it'll open up.
But then how do you get NDVI?
Stick it in as the third argument to add layer.
I got you.
So we've gone through this exercise because I want to point out something very specifically. In my script, I have variables, I have bands, like this image has multiple bands that are named, and I have the names of layers. That's 3 different ways to name something, and you'll get a little confused here. Like my Landsat images have 11 bands named B1, B2, B3, B4, B5, B6, B7. They are in an image named composite as a variable, and it has been added to the map as a layer called layer 1. So 3 different names there. I can make them all the same name if I want, except I've got 11 bands and I can't rename all 11 bands to be called composite. But you kind of need to understand this is just different kinds of naming depending on where that's happening, either in your code or in the image as the band names or on the map as the layer names. Okay? That makes sense a little bit? All right. Anybody having trouble? We're ready to go forward? Okay. So we just learned how to do NDVI to one image. If we want to do something to a whole bunch of images, What are we going to do to it? We're going to map a function. We need a function to map. So what we're going to do is we're going to take one of these two methods and stick a function around it so that we have a function that creates NDVI, and now we have something we can map over our entire collection to compute NDVI with. So I am going to erase one of these. You might just want to comment it. And let me show you another shortcut. If you highlight a bunch of code, on my Mac, Control/ comments out that entire block of code. On your Windows box, probably Control/. Okay? But I'm going to delete it because I don't want it anymore. And for what's left, I'm going to stick a function around it. That doesn't quite do what I want. It needs to return something. And half of you will get this wrong, so pay attention for a second. This function gets something and calls it x. Gets past something, gets past an image probably, and calls it x. The code here needs to use x. Previously it was using composite built way up there. You need it to use x so that it's the image that came in each time it gets called. And I like to name my variables the type I think they are, but when I call this image, everybody gets confused. But I could just say image here, and then image in all three spots here. But I'm going to go with x. Okay? Now, we have a function that will compute NDVI. When you write functions, you should test them. So instead of sticking NDVI2 on the map, we're going to call our function on our composite and see how that works out. And it looks exactly like we had a second ago. Okay? This is just a testing step. Use my function with one of my images, or my image. And it works. So we think we've got a thing we can use here. Or I think we've got a thing we can use here. That was a little fast and fancy. Anybody have problems with that? Do you need me to cover anything again? Just say it one more time. I'll wait. Go ahead. When you run, well, we'll get to that in a second. Okay. So we are going to map this function over our entire collection. Any guesses what that looks like? Oh, brains are getting full. Okay. We are going to make an NDVI collection. And it is our Landsat 8 collection. And we call map with our function. Map this function over that collection. And we're going to stick that on a map. If you are inside the parentheses with nothing after you, then it'll complete the variable names.
But if I have the variable name written, it doesn't.
If you have anything there, it won't. It doesn't know if you're trying to do a variable or, yeah. That's a very special option of give me all the variable names. It only works on a blank, the rest of the line being blank. All right. Does everybody have a very ugly NDVI image collection? Raise your hand if you don't. Really? Oh, okay, we'll give you a second. You need help or you just don't have it? Jump in, Nick. Nick will come help. Anybody else? You good? No? Yeah? Yes? No? Yes? No? Command, I think it's Command Enter, but all the shortcut keys are here in the help menu. I think it's Command Enter. Okay. All right, so we took our entire Landsat 8 collection, we filtered it down to 1 year, we applied NDVI to every single image, and we stuck what we had on the map. The map is composed of all those NDVI images, but the last image is on top. So the image that you're seeing here is the December 27th image of 2017, and here it's the December 23rd image. They're just last on top compositing. And so it's an ugly image, right? It didn't do anything. It's NDVI, but it's just last on top NDVI. Where we were headed was trying to make a max NDVI composite out of these. And we already know how to do this. You just don't quite remember it. If we simply take the max, then at every single pixel, you get a max value. And you end up with a, hopefully, very pretty image. If you like NDVI. It's just grayscale, so maybe your aesthetic is different than mine. But I think it's a pretty image. Excuse me. Almost the same, except the band names don't get renamed this way. Whereas if you use the reducer, then it ticks the name of the reducer on the end. Max NDVI, not average. If you want average, change max to mean. Max NDVI. So I'm doing this for the whole United States here just to see how long it takes. It should be about 40 seconds total. There's not nearly enough smiles here. You just processed 800,000 images to max NDVI composite. You're supposed to be excited about that. How many bugs?
One additional or just NDVI band?
How many bands? One band, because all we did is return to the whole, all we did was return an NDVI image. We can add this band to our previous image and get all 11 bands plus NDVI if you want.
So if you want to do actually band classification, band cover classification, not only vegetation, but
You might want.
to add that to the original or just
Totally depends on what you're looking for and how you go about it. The question is, do I want to classify on NDVI or do I want to classify on surface reflectance or TOA reflectance plus NDVI? Science, man. You know, you probably don't want to classify on either. You probably want to classify on something else. We'll talk about that tomorrow in terms of how to build a feature vector and what to put in it. You don't. You can reset and it'll all go away, but you can't stop in-flight progress.
I just want to understand, so
What is the what function?
The first line of the add NDVI.
So this function, this line converts every image into NDVI. It takes,
It's a stack of images.
it is a stack of NDVI images, yes. And then this takes the max through that stack at every point. Cool? Happy? Kind of happy? All right, so I talked to you about method chaining. I kind of want to show you the ludicrous extreme of method chaining, because really, sooner or later, I'm going to send you some code and it's going to look like this, and I want you to see what's going on. You don't need to change your code. The functionality is not going to change here at all. I'm just going to show you how I would write this code if I was writing it. We're not even using composite anymore, so I'm going to comment it out. Actually, I'm going to delete it. Well, I'll put it back if necessary. I would do so that's our whole program. Image collection filtered to a year, mapped to NDVI, maximum, one line. Don't even need the variable. It is possible, but unlikely, I would send you code that really looked like this. It's happened. I've written code like that. I'm not proud of it. But zero variable code. No variables. If you understand, if you can get the comprehension out of the code without adding the variable names, go with it. Like I kind of like my code. I don't like my code like that. I like my code like this. Okay? I don't care about all the intermediates unless I'm going to use them. So I don't have intermediates. I don't keep them. This bit about sticking the function right inside of the map call is called an anonymous function. It doesn't even have a name. It's just a function right there, but it works just fine. And so it is not uncommon to see code that is 40 lines of code that does an entire workflow with no variables. You didn't need them. It was all one output of A is input to B, output of B is input to C. You just chain them all the way through. Doesn't always work. You may need to bring in other things. There's a few places in the library where we break this flow intentionally. But in general, the Earth Engine libraries are built to support this on steroids, right? It's just, this is how we write code. Maybe you like it, maybe you don't. I just wanted to show it to you. Okay? And just to make sure I didn't break anything. Yeah, it works. All right, so I'm going to undo that back to the code that you probably have. Unless, yeah, let's go backwards, okay? So I will back up to there. And that should be what you've got. Okay, so now we have, oh yes? Command, on the Mac it's Command Z, on the Windows box it's probably Control Z. And Control Shift Z to go forward again. Yeah. Okay. We have a annual max NDVI composite. One issue about this composite is that you don't know where those pixels came from. Could be the beginning of the year, could be the middle of the year. You don't really know, and you probably care. Like, this is the first question that someone hasn't asked it yet is surprising. You probably care. So we're going to do two changes to this code that are probably more likely what you would want when you're doing some kind of scientific analysis here. The first thing we're going to do is what was asked a minute ago. We're going to add this NDVI band into our original image so that we keep our original 11 bands plus our NDVI band. And that's really simple. Here, instead of just returning NDVI, we're going to return our original image, and we're going to add this to it. But this image has a weird name, or a weird band name. It's called constant, or it may be called B5 or something. We're going to rename it to be NDVI. And so when we run that and inspect our map, we will see that our max NDVI result, which we haven't quite worked on yet, is all the bands plus NDVI. Oh, one more thing I forgot. We took a detour there to work on composite, and I had to get rid of my TOA. But I really want to be working on the TOA, and I don't need my composite anymore. So stick the TOA back in, because it's calibrated, right? These are uncalibrated values. Let's go back to using the calibrated values. Give that a second. Yeah. Okay, so if you didn't catch it, we've gone back to TOA, and we're not using the composite anymore, so we just commented out. All right, so that is our original image, all 11 bands, plus an NDVI band, but we still don't know where those pixels came from. So to do that, what we're going to do is we're going to give every single image a date band containing the day of year that that data came from. And that was a lot of words. Let me show you how it works. We are going to day of year is the image's date. And we already know how to get day of year. We did that in our very first step. Get relative day and year. So that's the day of year for this image. And we're going to stick that into a constant band for the whole image. And there's a little weird thing of Earth Engine I want to point out to you at this point. That's why we're going through this particular step. I then added that band into my image as well. Okay? Now if we run it, we should at least have the right band. It isn't quite finished. Oops. Ah, I got caught myself. This is called X, not image. I told you I call them image. So, but yeah. Now when we inspect, we have a date band. It isn't right yet. We're still fiddling. It isn't all finished yet. But at least our images contain NDVI and day of year. Okay. I hear less typing. I think you're with me. Everybody good? Okay. Nope, not yet. It adds the day of year as a band. It's a constant band. For any one Landsat image, the number is 305 for every pixel in that image. And for the next image, the number is 307 for every pixel in that image. But when we do compositing, we can have it get the right day to go with the pixels that we're trying to use. I'll show you that in 1 second. Okay? Everybody's with me. We've got a stack of images. Oh, not quite. Do you need help or just a second? Right. So I made the same mistake. Our function is taking x, and we want to get the date from x. I typed image. Oh, let me see then.
I have X.
Okay, so we're about to redo things a little bit different than we did before. We were making an NDVI, max NDVI composite by just computing NDVI and taking the max. Now that we have a 12 or 13 band image, what max is doing is it's taking the max of every band independently, including the date band, and what we're seeing is not what we wanted. We're getting independent maxes. That's not right. We still want to get our maximum NDVI composite, but instead of max for all bands, we want the max NDVI point in time at each pixel and all the other bands that come from that point in time. And so if you're familiar with it, this is called a, I don't even know if it has a name. If we were doing the median, this would be a medioid. Technically, this would be a maxioid, but I don't think that's a word. So we're finding the max in one band and taking all the other bands that go with that point in time. There's a couple different ways to do it, but the easiest one is just called quality mosaic. We are going to take our collection, and instead of taking a max, we're going to do a quality mosaic on the NDVI band. And it does exactly what I said. It looks at the NDVI band, it sorts them at every pixel, it takes the maximum, and for that pixel and time, it takes all the other bands in that image. Quality mosaic takes the values in this band, whatever that band is called, sorts them, takes the maximum, and then the values for all the other bands that go with that maximum. Not image, pixel. This is on a per pixel basis. So on this pixel, the max NDVI occurred at day 185. And so all the bands come from day 185 for that pixel. The very next pixel over, the max NDVI might be on day 190. And so it takes all the bands from 190. So it's a per pixel selector.
How about if I want to extract the location of the maximum value of the index?
Whole different thing. You'll get to that in just a second. So, did it work? I don't need my collection anymore. It's just taking up time. And I will go back to Washington, and that's just taking up time. And I fear I've done something wrong. No, I'm not. My NDVI looks like it's upside down. So important safety tip, never let a software engineer work on your brakes. Because we build something and then we try it and it doesn't work. And then we try it again and it doesn't work. And we try it again and it doesn't work. And that doesn't work with brakes. I'm just saying. Whatever I've done here, oh no, that's a 0.7. That's a reasonable number. What's going on? NDVI of 0.7.
You want to select the NDVI?
Ah! I went the right band. Yeah, exactly. Thank you. I want to look at the NDVI band. It was working, it's just showing me the wrong thing. There we go. Pretty. So if you missed that, I just wasn't specifying which band. So I was getting that terrible band combination of coastal aerosol, blue, and green. You use a function called reduce region, and we're going to use it in a different context in just a second. So you'll see how we can cover it at that point. Okay, so do you know what a medioid is? Okay, so we're not doing median, we're doing max. And so we're trying to do a maxioid. Find the maximum NDVI and take all the other bands that go with it. Quality mosaic for the NDVI band does that. It makes a mosaic by taking one of the bands as a quality indicator, and it maximizes that band and takes all the other bands for the same point in time. We could call it something like medioid, but we're not actually doing median. So.
The dot mosaic command, what is that?
Last on top just squishes them down. So train alpha blending from top to bottom.
It's not median.
Nope, just a straight up mosaic. Sure.
Your max NDVI for each pixel and selects all of the values of that singular max pixel. Okay.
Yep, exactly what it does. Okay. We've now got a scientific quality max NDVI image and reflectance data that goes with it, give or take. Don't publish a paper on this. Do a better job. What I'm going to do now is stuff with this image, with this mosaic. Composite, mosaic, what do we call this? Mosaic. Composite and mosaic are the same thing to us. The first thing we're going to do is try to find the mean peak NDVI for Delaware. All right, so for a big region that's going to be on top of Delaware where they grow a lot of stuff, we're going to figure out what might be the mean peak growing season. It may not be, but that's what we're doing. We're just going to take all of the peaks, all the days of years that go with these max NDVI points and just get the mean of all of them. And maybe you have some hypothesis about peak growing season. This is how you go about it. Okay? So the first thing we need is Delaware, or at least someplace where they grow a bunch of stuff. So this is quite green. It's quite growy. I'm going to suggest that we just take a polygon here, and it doesn't matter which one. We could get the whole state boundary for real if we want, but I just need a region. So click on the polygon tool and draw a polygon. And if you do this in Delaware or you do this in South Dakota, I don't care. I just want you to get a region somewhere where they've got NDVI stuff. Okay? So that's step one. That's where we're going to do our aggregation. We're going to aggregate numbers inside that polygon with a reducer. The next thing we need, oh, everybody good? Click on the polygon, click some points. It creates a geometry up here in your import section. And that thing's called geometry. Okay, now that we've got a region, the other thing I want to do is I want to get rid of all the pixels that have low NDVI, because I'm talking about peak growing season, and I don't really care what the peak is of asphalt. That day of year doesn't mean anything to my computation. So I want to get rid of all the asphalt and all the buildings and all the other stuff that's not NDVI specific stuff. So we're going to threshold our image with some threshold value. So we take our max NDVI composite, and we're going to update its mask to get rid of stuff we don't want. And the stuff we don't want is the NDVI band greater than 0.6. That's the stuff we do want, and everything else will go away. So way back at the beginning, I told you every band has its own no data mask. We're just going to update that no data mask, erasing pixels that don't have an NDVI of at least 0.6. NDVI greater than 0.6 is a Boolean. It's either 0 or 1. Either it's true or it's false. Everywhere that's 0, erased. Everywhere it's 1, left alone. So we just erase all the values we don't want. Every band has its own no data mask. It's called mask. You can get to it. It's actually a whole other image. You can fiddle with masks as images all you want, and that's what we're doing. We're making a new mask, and we are updating the existing mask with that new mask. Okay? So now we've got pixels with vegetation in them, a region in which we're trying to compute our mean growing season number, and yeah, we'll start off with mean growing season number first. There's another thing I want to do in a second. So mean day of year is our threshold, and we're going to aggregate a bunch of pixels in this image, and we do that with reduce region, because we've got one region. And since you've seen me do it 6 or 7 times now, I'm just going to tell you I'm going to autocomplete those arguments and fill them in. Sorry? Control space on your Windows box unless you've got it remapped to something else. There's not that many of them, so if you can't make it work, there's not that many of them. So reduce region wants at least 3 things: a reducer, a region, and you could stop there, but you never should. You should always specify at least a scale and maybe a whole projection, because now you're going to be working with actual real pixels, and you need to specify what projection you want those pixels in, because otherwise you could get dramatically different results. If I use 1 degree pixels here, I'm going to get a crazy number. I want to use real pixels. And so Landsat data, 30 meters. Now before you click run, I will point out that what we're trying to get is our mean day of year, but we are reducing our entire image, all 13 bands. that's 13 times more computation than we need to do, we're going to do it, but then I'm going to tell you don't do that. Okay? So we'll click run. We'll look at the result. And hopefully you got this error. If you didn't get this error, that means you have a little bitty polygon and you're fine. But this is not actually an error. Okay? And half of the point, we'll call it 10%. 10% of the point of this workshop is to get to this error. We got there. Yay! We're almost done. This is what we call a blade guard. So in the US, when you buy a table saw, there's a thing on top of the blade that keeps you from cutting off your hand. And the manufacturer is covered for when you remove that blade guard and run your hand through it and chop off your fingers. This is exactly what we just ran into. You tried to run your fingers through the saw blade, and we told you, hey, maybe that's not the best thing. There's a limit on the number of pixels that you can just use. And it's, I think, 100 million. I think that's what that next number says is 100 million. That's not really a limit. That's just a warning that, hey, you're about to do something that might take some actual computation. Are you sure? If you're one of my academic users, I'm paying for the computation you're about to use, and I want you to be sure. If you're about to aggregate 1 billion pixels or 1 trillion pixels, or you'll see in just a second, 27 exabytes worth of data, I want you to be sure that you really want 27 exabytes worth of data before you actually click run, or before it actually does it. So this is a warning that you're about to do something larger than the default threshold. And the reason we got it, this is a reasonably small area, the reason we got it is we're trying to do it to 13 bands of data, even though we only care about 1. So when you get this message, I will first show you how to work around it. You do that by adding a function called maxPixels. And you should never, ever, ever do this. First of all, it won't work. Because of rounding, you're actually going to have to add 1. Don't do that either. Because you're about to spend a bunch of money, and you might have got it wrong. So I want you to think about what you've done. That's the whole point here is, please think about what you've done. Because we have a user. I teach a debugging class. In the debugging class, I take real things real users have done and make fun of them anonymously, but to show you what not to do. We have a user that said, I'm using EPSG 4326. I'm smart. I've used EPSG 4326. I happen to know automatically that it's in degrees per pixel, and so I want to use 0.0083 degrees per pixel, because that means 30 meters in Landsat terms. Except scale in Earth Engine always means meters. Always. There is never a place anywhere in Earth Engine where scale doesn't mean meters because of this confusion right here. It always means meters. So this user just asked us to aggregate using 83 micron pixels. And he got an error message that looked like this. Wait for it. He did this.
No.
He added 1 to it, and then said, why didn't my code work? And I said, dude, K, meg, gig, tera, peta. 59 petabytes of aggregation. That's why it didn't work. Even if it did work, it's not going to finish in your lifetime. You did a bad thing. So never, ever, ever cut and paste that number, because I will end up making fun of you in my next debugging class. All that said, I cut and paste that number frequently, but really, the important thing to put in your brain is 1 e to the 9th is safe, 1 e to the 12th is iffy. If the number is bigger than 1 e to the 12th, it's not going to finish, don't bother. So when I hit this error, I just immediately go, oh, I don't care. I believe 1 e to the 9th is fine. Don't leave 83 microns in here. Go back to 30 meter pixels. And if 1 e to the 9th didn't work, oops, I did something goofy. It just so happens that this will work. And I still am aggregating all 13 bands. I'm not supposed to be aggregating all 13 bands. I just removed the blade guard from the saw, and I ran my pinky through the saw. It's only a pinky because I only did a little bit, but I just did a bad thing. I didn't think about what I was doing. I just stuck that number in there. And so maybe this finishes in a minute or not. Maybe it doesn't. But what I really care about is just the day of year band. Oh, there, see, I shouldn't have done that. So what I want is to select the date band and only aggregate that band, because that's really all I care about here. And that will be 13 times less computation. It will run 13 times faster. That message actually means that a bunch of us was doing the same thing at the exact same time. So just rerunning it probably would have worked. And in a few seconds, we'll get an answer for mean peak growing day of year for Delaware, give or take.
If we didn't get the error, just didn't have a big enough polygon.
Right. You fit in the 100 million pixel limit by default. 100 million, 10 million, I never remember that number. You probably have a typo, but here comes Nick. Okay, so my aggregation finished. It gave me a dictionary, which is actually called an object in JavaScript speak, unfortunately. And inside of it, there is one value named date, because that's the band it came from. And my mean peak growing season day of year is 205. Publish. Any questions about that? Okay, let me show you some shortcuts. That took a little bit of time, and in fact, if we had a bigger region and a lot more data, it might have taken a lot longer. And so if you just want to get a rough number fast, we can do a bigger scale. And that finishes in a second. And it's still pretty close, right? I said earlier, most of the stuff we do is pretty linear. The difference is half a day. I know it's an approximation. I told it to be an approximation. In fact, I told it to be an approximation 100 times lower resolution than I care about, but it's still close enough. And if you just want to get an approximation, just change your scale. You can make a smaller region. That may not be what you want. You may want the whole state. You can use a lower scale to get a faster approximation.
So I got the like 14 properties inclusive of date.
You didn't select here.
Select date.
Can you explain a bit about what exactly is the mean day of year? What did we compute here?
I made an image containing the day of year of the maximum NDVI for every pixel. And now I'm taking the mean of all of those in the places where there is vegetation.
Right.
So
So
the-
we took the maximum NDVI ones and the band called day of year.
Yep.
And that is what we average.
We are averaging that, correct. Okay? So if you want to do regional things, and sometimes your region is just a point, like maybe you want to extract the entire time series at a point, there's a geometry, we call that a region, then you could do the exact same thing, and maybe you want to do toList and a single point, we'll call it geometry 2. So for this point, running reduce region to get all the day of years at that point, that won't work because there's only one. Yeah, if you want to get it from a whole collection, it's a slightly different configuration. But my point is there's a whole bunch of reducers and a whole bunch of different ways to reduce, and now you know how to do that. So this example won't work. Yep? We use the pixel nearest to the point, pixel whose center is nearest to the point. Yeah, because it's one point, yes. If you want pixels around a point, buffer the point and make a polygon. Okay? Questions?
So we put the point inside that list.
What?
So particular points, how do you,
Well, so the thing I'm aggregating is one image. So the point is just one value. So that's not what you were asking. You're asking, how do I get that point for all images? There's a function called getRegion, which will do that for you. There's a simple function called getRegion. Here's a point. Give me the time series.
So if I have to like compare two regions in the same area, like this polygon, I want to split it in two and compare their max value.
Make 2 polygons and run reduce regions. Yep. You just apply reduce region to the right image. Get the right image, apply reduce region to it. Okay, so the next thing you might want to do, having done computations on top of your imagery, a thing you might want to do next for your publication is export your image, right? I want to include the image in my paper. I want to put it on my website, whatever. So I'm going to show you how to export. And don't feel bad about it. We know that Earth Engine doesn't do everything you might want to do. And so a whole bunch of people actually don't even use Earth Engine except to get some data. So they download a bunch of Landsat data out of us, and they go off and they use R, and they get done. And that's all we care about, is that you get done. If that's the best way that you can use Earth Engine, great. If you're about to load a bunch of imagery into R that you just downloaded and take a mean per pixel, I got a tool that may make your life a little easier, but I don't really care if that's all you want to do. So don't feel bad about saying, I want to export, I want to import. We want you to be able to get done. So export works almost exactly like reduce region, because you're doing kind of the same thing. You're visiting every single pixel, and instead of counting it or adding it or something like that, you're just putting it in an output file. And so what we're going to do is export an image, and there are 2 places we can export an image. This requires a little bit of explanation. You would hope that you would say, OK, my image is pretty small. Just give it to me. Let my browser download it, and I want to be done. And you would be reasonable in that assumption. Except it is possible to chain together enough computation and try to do enough stuff that it actually takes us 10 days to generate your image. And that image might be 400 petabytes. Like, that's totally a thing that can happen. And that is not OK for us to say, OK, hold your browser open for 10 days, and here comes a 400 petabyte image. And so since that is a possibility, we actually have to code around the fact that everything has to go through that same path. So we don't just say, here's your image. What we say is, tell us someplace we can write your image regardless of how big it's going to be, and we'll write it there. And your 2 options are Google Drive and Google Cloud Storage. Because when we're writing these images, we're often writing a few 100,000 tiles at a time. Like, there's a lot of machines writing, can be writing to your image all at once. And if we were to write directly to, say, your FTP site or someplace that is one of your computers, my 100,000 machines hitting your one computer all at once will melt your machine. And so we don't allow that either. We have to be able to write to some place that can handle a concurrency of 100,000. And to us, there are 2 options, Google Drive and Google Cloud Storage. So we've got to have some place we can write to for a long time and a place we can write to very, very fast, and those are our options. That said, as a Google user, you automatically get 25 gigs free in your Google Drive, and so you can just write to it and life is good. When you try to write that 26th gig, it will fail. So if you're trying to write a 50 gig image, it just won't finish. You can buy more Google Drive storage. It's like $100 a year for a terabyte, maybe even less than that. I don't remember, but it's pretty cheap. And if you happen to be at a university or one of the federal institutions that has an apps domain, you often have unlimited drive storage. So I was actually at a university and someone said, no, we have unlimited storage. And I said, no, you don't. And he's like, no, I'll go find it. And he went and checked, and it turns out they have an exabyte of storage each, which I want to see someone fill up. I think that'd be kind of fun to try to fill up someone's university account with an exabyte of data. But, so you might have to pay for a little bit of storage if you want to export to Google Drive. The other place you can write is Google Cloud Storage, which is just an online file system, basically. As a Google user, you automatically get 5 gigs free in Google Cloud Storage. if you write the 6th gig, they charge you 12 cents per month per gig, which works out to, I just did this math, $800 for 10 terabytes for a year, so less than $100 a year for a terabyte. It's an alternative to drive, whatever. I would very much like to have a place where you could write an unlimited amount of storage and not be charged for it. But if I did that, you would write an unlimited amount of storage in there and not be charged for it. And the company kind of frowns on that. So we have to have some place that's metered for you to write to. You can always write 5 gig or 10 gig at a time, pull it out, and write the next 5 gig or 10 gig and never be charged. But that, if you want to work around the system that way, then you have to work around the system that way. So back to exporting. We're going to export our image in this polygon to Google Drive. And to do that, we're going to end up making a task. So export image to Drive makes a task. There's a question?
Yes. How about exporting to clusters or Linux servers?
No. Again, you have no idea how many computers I'm trying to hit your cluster with, and it would be a very good denial of service attack if we let people try to do that. So no, it makes administrators very unhappy. So our image will be we're going to export our threshold images, our threshold image. We'll give it a description of my image. I don't care about anything down to region. Scale. I care about CRS. I should care about, but I'm lazy and I don't. And I don't care about the rest. I might not care about the rest. So when you click Run, your Tasks tab lights up, indicating something's going on there. You can click over to that, click the Run button, and start your image. Oh, my image failed. Dang it. That image took 7 days and then failed. So it is possible to chain together some really complex stuff. This image, depending on how big your polygon is, should export in a few seconds. If it doesn't otherwise have problems. I said earlier, but I'll repeat again, geotiffs and shapefiles. That's what we import, that's what we export. We strongly recommend GDAL if you want to convert into other formats, and it's usually just a one-liner to be able to do that. Say again? Yep. Uploading and downloading work very similarly. We started a task for download here, and for uploading, click on the Assets tab, and then just click Table Upload or Image Upload. Yep. If I tell you, you will be sad. So I'd rather not tell you. But the answer is it will take the scale of the first band in the image as well as the projection of the first band in the image. But you should never, ever rely on it. You should always specify a scale, and you should probably specify a CRS. That one I'm yeah, no, like I said, it'll do what you're expecting most of the time. So it is perfectly possible to export and reduce, never specifying a scale or a CRS, and it will take the one from the first band. It will take the first band. I don't know why it's taken a long time, but it is.
So is it safe to go with the port 326 PSG, or what is the way around specifying that?
I'm sorry?
The CRS reference?
Well, you should care what that value is. If you don't care what that value is, your reviewer is going to care when he looks at your paper.
Yeah, so I was trying to figure out what is the correct one for local, and sometimes it's very
Yeah, it's Albers equal area or something like that. It just depends on what you want. That's totally dependent on what you're trying to do. Oh, there was one more thing I wanted to show you. So if you were trying to, we made a threshold image here of the pixels that have vegetation in them, and we threw away a bunch of other pixels. And so another thing you might want to do is try to figure out the area of the vegetation that we've got left, right? That's a common thing you want to do, aerial statistics. There's a really cool thing you can do in Earth Engine that you can't do in other places very easily, and that is projection-independent aerial statistics. So back up here on our reduced region, instead of doing mean day of year, I want to know the area of the vegetation. And I don't really care which band I use because I just want to know if I have a pixel at all or not. Let me rephrase that. Let me try that sentence again. Inside of Earth Engine, we have a special image called pixel area image. That is an image that knows the area of every pixel in any projection. So anytime you ask that image for a value, what you're getting is the area of that pixel. And if we take that image and we update its mask with our threshold, I could have done this more elegantly, but I'm just going to cut and paste it. Then we have erased all the pixels that have no vegetation. And now we can just sum this thing. And it doesn't matter what projection or scale we're using, because the area scales with the projection appropriately. So if you were doing this outside of Earth Engine, what you would probably do is download this image in Albers equal area, and you would count the number of pixels in an equal area projection. You don't have to do that anymore. You can just say, what is the actual area of every pixel, and sum them in whatever projection it is that you happen to be working in. It could be the native projection, it could be EPSG, it doesn't matter which one you pick, because the answer will be almost exactly the same in every one of them. In this particular example, I am thresholding on NDVI pixels. And as my pixel size gets bigger, the NDVI of that pixel changes. So I'm actually going to get slightly different answers as I pick different resolutions and different projections here. But if that's not the case, you can do this in any projection at any resolution. Okay, so we're summing a pixel area image to get areas. And it is resolution independent. Cool? It's cool. I think it's cool. I'm a nerd, so, you know. Okay, questions? I got one more thing to show you, unless there's questions about this.
I have a question.
Yep.
Well, for example, if someone is doing a global analysis, how would you select the entire world as your
Polygon?
country?
Yep. There's a hacky way to do it, but it's really the best way. I'll explain this in 1 second. I want to be able to see it, though. So this is a 6-point polygon using non-geodesic lines that I stuck on the map. Oops, I didn't stick on the map. Add layer. I'm sorry, I'll get there so you can see it. I don't care about the max. Come on. What did I do wrong? Oh, I don't care about mean DOI right now. And I mistyped one. -88. So there we go. So this is again, a 6-point polygon using non-geodesic edges, starting here, hitting 0, going down, over, over. The reason that it's 6 points instead of 4 points is that if you specify minus 180 and plus 180, we will collapse that to 0 because it looks like they touch. So we stick a point in the middle. So minus 180, 0, plus 180. Touching the poles is really tricky when you're doing cross projection math. Don't do it. Stop at 88 or 89. Pick some reasonable number that doesn't include 90, because in many cases, as you're going from one projection to another, if the pole's included, there's a singularity and things blow up. Don't do it. Okay? If you happen to be a polar person, I'm sorry. Please do everything in polar stereographic and avoid the equator.
So in our case, you just added the area basically variable. Is there a possible way then to basically specify to map over the screen the image that you can or the drive, I guess? Like do that rather than say separately adding them CSV files or something like that, or images, but having them all be in one before you export?
You can stack together bands from any number of images you want and export them all together, but it's going to go into a single geotiff, or one geotiff per band because that's an option. And there are limitations on geotiffs, so they can't support multiple projections per file. I think they can support multiple resolutions, but not multiple projections. So yes, you can, but yeah. You actually can run multiple tasks in parallel, so running multiple images will actually probably be faster than doing it all at once. Okay, so two last things. Yeah, okay. Two last things. First of all, the important one is how to get help. Up here under the help menu, there is what we consider to be a bit of a flow. The very first thing for getting help is go to the user's guide. Our user's guide has 400 pages of documentation, almost all written by Nick, and he would very much like you to read the stuff he wrote. And more or less, all the questions you're going to have are somewhere in there probably. But it is 400 pages, and it might be tricky. You just search for some good keywords. You guys know how Google works. Hopefully, you'll find what you need in that documentation. If you don't, the next step is to go to our help forum, also called our users group. It's a Google group. It's got 7,000 Earth Engine users who ask questions and answer questions. I answer a lot of questions on that, but I travel. And so some of our, like I haven't answered any questions for the past 4 hours on that users group because I've been here doing this, right? But when I'm on a plane or I'm sitting in an airport or I'm at home, I answer questions kind of frequently. I do 50 to 100 a day sometimes. And when I'm busy, like right now, some of our users take that as a challenge to try to answer more questions or questions faster than I can. So it's often the case that actually 15, 20, 50 people who can answer your question are actually just reading their email. It's like, oh, here's a question. I can beat null to it. And they answer it, and it comes out. And you might get an answer to your question in probably not a few seconds, but not much more than that. Like, it is easy to get answers to your questions in 5 minutes. But only if you're nice. And by nice, I mean you need to have a well-formed question with an example bit of code with not 500 lines commented out and badly formatted, right? Ask a question well, and people answer it quite quickly. So the way you do that is you say, first of all, you write good code. I hope I showed you some ways to write good code, indentation. But you say, I'm trying to map tiger habitat in Tanzania by using NDVI maximum something something. Here's a link to my code. It's not working because I get this error. Can anybody help? And the way that you get a link to your code is this button right here called Get Link. You click that, and it changes your URL to this long hashy, this long string of numbers. That is now a copy of everything in your code editor and your map that anybody else, when they open that link, will be able to see what you've done. Exactly, puts them in exactly the same state you were in with the same error and everything, hopefully. It is possible to cite those URLs, but they're weird, so I don't recommend it. but we work hard to make sure they never expire. But clicking on that Get Link button makes your code publicly available to anybody that can actually access that link, anybody that has that link. The links are cryptographically secure, so no one's going to stumble on your link by accident. That's just highly, highly unlikely. But you format your email message with what you're trying to do. Here's a link to my code. Here's the error I'm getting. Send it off to the users forum. You should get help pretty quick. When things aren't working, like things just break, occasionally you'll get an internal server error or something like that. That means you discovered an Earth Engine bug. Send us feedback and say, I got an internal server error, and then we can fix it. Otherwise, you'll just hit it again next week. So definitely do that. When you have a data set that you want, go to our Suggest a Dataset link and tell us, hey, I like this data set. Can you bring it in? And like I said, people vote on those, and then we bring in the ones with the most votes. OK, so users guide, help forum, nice message, get help, you're off and running. Now, the last thing I want to show you is this thing that we've recently launched. Yep. Yeah, just click on the button, and if you just signed up, you got an email with an invite to join the users forum in it. If you signed up a little while ago, that invite has probably expired, so just click on the button on the forum that says Contact the Owner, and Nick, who's sitting in the back, will add you right now. Because that's what he does all day long, and he hates it. OK, so I want to show you this last really super cool feature, and I hope you will agree with me that this will be transformative for you. We're not actually going to type any code. We're just going to look at the last script in our repository called linked maps. And before we look at any code, I'll show you what's going on here. This is a Landsat composite made similar to the way we've done it, visualized 3 different ways: red, green, blue, near infrared, and the thermal band colorized. We did all this, except for the thermal. We did something just like this. But these are 3 different maps that drag together, and a little label that I stuck on each map. This is a little tiny application. And now there's a button up here at the top of your Earth Engine code editor to publish that as a web app. So we will turn your Earth Engine code into a web app anybody can use with 1 click, 5 clicks. But it's right there. Okay? And here's a bunch of apps that I've made. Here's one. Here's that one. Well, let's go here. Go to the Link Maps app. It looks an awful lot like the Earth Engine app code editor with no code. People can't get to your code. If they hunt really hard, they can see your code, so it's not secure or anything. But your boss is not going to pull down that code and start fiddling and say, well, why didn't you try this? And also, they don't have to be logged in. So any user can come and use your app. So I'm trying to make it possible for you to influence your decision makers with a nice, easy app without ever having to write any HTML. You don't have to write any JavaScript other than what the JavaScript we've already learned how to drive Earth Engine with. And you don't have to be a web developer. Click the button, publish your app, do what you want. You can put charts in there. I'll show you the one that I just made for the UN. This is that app embedded in Sites. And what it does is it lets you get aggregated statistics. Oh, you can't see that, can you? Let me try that again. There we go. So this is an app embedded in Google Sites. The app lets you get statistics for different regions for surface water from the JRC surface water product that we talked about earlier. Charts, nice interactivity, pick a different set of boundaries. This is all not hard to do directly from Earth Engine. So code your algorithm up in Earth Engine, click publish, we make you an app. You are off influencing people with your app, I hope. Yes?
Those are discoverable or those are private?
These are public, 100% public. Private ones are coming, but not yet. Now, you might think, well, that's an awful lot of fiddling. Let me show you how easy it is. Here is our app. You've already done this. There's a point dropped on top of San Francisco just so that that's where it's working. That's in the geometry. Landsat collection, filtered to a date, filtered to my point, simple composite. We did all that. You know exactly how this works. We get a composite. We make 3 sets of visualization parameters to make the colors. We've done that. And here is all the code to make an app. That's it. 10 more lines of code, and you can publish an app. I'll walk you through this. For each one of these visualizations, I'm going to make a new map. I'm going to turn off all the controls, otherwise there's just a ton of zoom controls on this screen. I add a layer to the map, which is my composite with the appropriate visualization parameters. I add a label to my map, which is the name of the visualization parameters. And I hang on to that map in a list. And you'll note there's a for loop here, and I've told you don't ever use a for loop. When you're working with UI components, it's OK. There is no way to map over UI components because they are never on the server. They only live in your browser. And so for loops are appropriate, and in fact, a thing you'll probably have to do there. This whole window down here is called the root window. We've been working with it as a map, so it's the root window with a map in it. If we get all the widgets, which include the map, and just reset it with 3 new maps, it erases the big map, drops in our 3 little maps, and we could be done. But we're going to add one more object, which is a linker, to make the maps link when you move them. Without the linker, they don't move together. They just move independently. And then if I recenter one of the maps, all the maps recenter. So it's a real simple app, but it's a real simple bit of code to make that app. If you do charting, if you do classification, play with the sliders for thresholds, whatever it is you want to do, they're all about this easy. Intentionally, this is a super simplified subset of JavaScript to handle sliders and menus and date pickers. And it's very easy to, in a couple lines of code, build an app and publish it to the web. I think that's super exciting. But one of my engineers said, I know how to put that on a phone. So you can go straight from, or hopefully soon, you will be able to go straight from code editor to phone app with one click. And now think back to my very first slide. I want you to go enable non-traditional users with whatever it is you know how to do and they don't know how to do. And I think that's the way to do it. Thanks for coming.